Welcome. Today we'll explain how to easily provision an EKS cluster with MetaDefender Core installed on it. First, we'll explain the recommended architecture for having MetaDefender Core installed on an elastic Kubernetes service or EKS cluster. There are three main resources that are important to understand. First, the load balancer. This will be the access point for the user or client to make requests to the application. Second, the EKS cluster will be created, where we will install all of the main components required to have MetaDefender Core run within an EKS cluster. This is the service component that will indicate that we need to provision a load balancer in our Amazon account. When selecting a load balancer type service in EKS, you will also need to install the Amazon Load Balancer controller. This is used to create and handle load balancer configuration within the Amazon account. After installing MetaDefender Core in the cluster, we will explain how to create the load balancer controller as well. The third component is the MetaDefender Core application running as a pod that will be connected to a Postgres database. You have two options for the database. One option is creating a pod for having a Postgres database running within the cluster. The other option would be using Amazon RDS service as Postgres database. For production environments, it's recommended to use the cloud Amazon RDS service. Now let's talk about how to easily provision all the resources within the provision script called MetaDefender Core Kubernetes created by OPSWAT. These script details are documented on the MetaDefender Core documentation page, where we indicate all of the prerequisites like Terraform, Helm, Amazon CLI, and kubectl. For setting up the credentials, it's important to set those as local environment variables before running the script. These local variables can be exported from a service account in Amazon. For activating MetaDefender Core, we need to indicate the license key as a local environment variable as well. The parameters that can be used by this script are indicated in this table. The main ones required to use are the action, in this case we'll select provision, the location, in this case we'll select Amazon, and then the MetaDefender product flag. In this case, we will only be installing MetaDefender Core. We can also run this script in GCP or Azure, which is covered in other videos. Some additional parameters we will use in this demo are namespace or the name of the cluster. Now let's move to a terminal where I have the command ready to run. Here you can see the name Metacore Demo and the namespace Metacore. Once we run the command, it is going to ask us if we want to run the latest version of MetaDefender Core, as we have indicated a different image version. We'll select yes. The next question is if we want to create the cluster with EC2 or Fargate. In this case, we're going to use EC2. Next question is, do you have your own access point, or do you want to create an ingress to access? We're going to choose, in this case, our own access point. This will generate only a load balancer to access through the service. The next question, do you want the load balancer to have an attached public or private IP? For the demo, we're going to select public IP so that we have a public load balancer. Next, do you have your own database or want to create a new database? When running the script, it is possible to indicate that you have your own database and then just provide the host name, the username, and password of the database within the script. In this case, we're going to create a new database running as external because we want the Amazon RDS service to be created for us. Provide the username and password. Now we see the summary of the selections. We can continue and see that the pod is initializing. The next command is going to be Terraform apply. That is going to list for us all the resources that are going to be created. We type yes here, and it's going to start to create all the resources for us. This can take up to 15 minutes in the case of an Amazon deployment. So we're going to pause the video now and get back to when the provisioning is complete. Okay, we're back after around 15 minutes, and we can see that the provisioning is finished. You can see that the script has downloaded for us the context that is installed in our local environment, and then we're able to start the installation of MetaDefender Core within the cluster. For this, we are going to use Helm, and the script is checking if the MetaDefender Core license is set up in the local environment. Now it will ask for the username and password for the MetaDefender Core UI. After confirming, it will start installing MetaDefender Core in the EKS cluster. We can see how the MetaDefender Core has created in the namespace MetaCore, and the next steps are configuring the load balancer controller script. That subscript is going to create for us a load balancer controller within the cluster that will automatically create a load balancer in the Amazon account. For this, we must provide our Amazon account ID. I will pause the video and input the ID. After inputting our Amazon account ID, we need to include the image load balancer controller, which is different per region. For this, we'll need to go to the Amazon documentation page and pick up the image for the correct region. In our case, it is going to be EU Central 1. We will confirm that it is going to install the load balancer, downloading for us the policy, and do the steps recommended by Amazon. Let's pause and wait a couple minutes. Now we see how the load balancer controller is installed. Let's run some kubectl commands to get the pod in the MetaDefender Core, in MetaCore namespace, and some information about the load balancer controller. We can see how MDCore pod is running and ready. We can now check the load balancer that is in the kube system. We see that there are 2 pods for the load balancer controllers. After that, we can also get the service to see what we have attached to it. Once we get the service with namespace MetaCore, we can see that it has an assigned external IP. This is the URL of the load balancer, which is attached to a public IP. Let's copy this URL and access the UI through HTTP with port 8008. We can now see in the browser that it is already activated. Now, just simply sign in. And this is how you can easily provision an EKS cluster with MetaDefender Core installed on it. Thank you, and see you in the next video.